Check 1, 2, check 1, 2. Lesson 82. It's called Greatest Common Factor, or GCF. We've practiced finding the factors of whole numbers. In this lesson, we're going to practice finding the greatest common factor, or the GCF. The greatest common factor of two numbers is the largest whole number that is a factor of both numbers. The letters GCF are sometimes used to stand for the term greatest common factor. So since they each stand for something, put a period in between them. GCF, greatest common factor, which is the largest whole number that is a factor of both numbers. So let's try it out. To find the GCF of the factors 12 and 18, first we list the factors of each number. So the factors of 12 is the numbers that can go into a number. So the numbers that can go into 12 are 1, and I always do them in their factor pairs, like 1 times 12 is 12. 2 times 6 is 12. And 3 times 4 is 12. And when the numbers are next to each other, you know that there's no numbers in between because it's only whole numbers. And the factors of 18, you can do 1 times 18. You can do 2 times 9. You can do 3 times 6. So then, after we find the factors for each number, then you go through and see which ones are the same. 1 goes into both of them, 2 goes into both of them, 3 goes into both of them, and 6 go into both of them. So our greatest common factor is 6. All right, so hopefully that makes sense. And then example 1, find the greatest common factor of 8 and 20. First, we find the factors to identify the common factors. The factors of 8 and 20. So we do 1 times 8, 2 times 4, and that's it. Well, and then the factors of 20, 1 times 20, 2 times 10, and 4 times 5. So then we go through and find our common factors. 1 is a common factor, 2 is a common factor, and 4 is a common factor. So our greatest common factor, which is the number that's the biggest that both of them have in common, is the number 4. Example 2. We can also use the greatest common factor to help us reduce fractions, and I'm going to show you how. Example 2, use the greatest common factor of 8 and 20 to reduce 8 twentieths. Well, what you do, so you have 8 twentieths, and so they're both, the GCF is 4, so we know we're going to divide them both by 4. Or remember how we do that thing where we can divide them by this fraction that equals to 1, okay? So that's what we're doing here. So 8 divided by 4 is 2, and 20 divided by 4 is 5. So we used the greatest common factor of 8 and 20, which is 4, to find the reduced fraction of 8 twentieths. Example 3. Find the GCF of 6 and 9 and use it to help you reduce 6 ninths. So 6, we've got 1 times 6, and we've got 2 times 3. And 9, we've got 1 times 9, and 3 times 3. So 1, 3, and 9. So we're going to use our common factors, our 1 and 3, and our GCF equals 3. So we're going to reduce 6 ninths by dividing each of them by 3. This equals 1. And 6 divided by 3 is 2. And 9 divided by 3 is 3. So our reduced fraction is 2/3. Lesson practice. Find the GCF of these pairs. A, 6 and 9. And at this point, I'm going to need you to draw a star right here and circle it. That way I know that you're watching this video. B, 6 and 12. C, 15 and 10. 15 and 100. D, 6 and 10. E, 12 and 15. F, 7 and 10. And then for the last three, it says reduce each fraction by dividing the terms of the fraction by their greatest common factor. G is 6/9, H is 6/12, and I is 15/100. You guys have a great rest of your day.